Welcome! We're excited to talk to you today about an innovative aircrew-mounted self-adjusting tether system built by Wolf Technical Services, under NavAir as a SBIR Phase 2 contract. Wolf Technical Services is a small business concern located in Fishers, Indiana. We are a multidisciplinary engineering firm that develops and designs products for defense, consumer, and medical industries. The company started in 1977 as a forensic engineering firm, performing accident reconstruction and product failure analysis. In 2005, we worked on our first SBIR focused on a crash safety system. Since then, we have completed 27 additional SBIR development projects for the U.S. government, including 8 Phase 2 SBIRs. Outside of the SBIR ecosystem, Wolf Technical has experience as a prime contractor for the U.S. Navy and Australian Army. We have 4 patents issued, including 1 for this system, and 2 patents pending. Our in-house engineering disciplines include mechanical, electrical, biomedical, optical, materials science, physics, automotive, aerospace, manufacturing, software, firmware, and civil engineering. Our principal investigators specialize primarily in mechanical, electromechanical, biomedical, and optical design engineering. But we've also produced results for robotics, control systems, instrumentation, and test equipment design. The company commercialization index is 70%. In addition to the 2 prime contracts I mentioned earlier, we are currently executing a Phase 2.5 and a Phase 2.5 enhancement on this project. The Navy challenge for this topic is to develop an air-crew-mounted, auto-retracting restraint system for use in tilt-rotor and rotary-wing aircraft. The primary transition target is the V-22, although other rotary-wing and other mobile crewed aircraft platforms in any service branch could benefit from this capability. The expectations for this system include improved fall protection and crashworthy protection for mobile aircrew in the event of a survivable aircraft mishap. The system must be self-adjusting so that the system retracts webbing and prevents slack buildup. The system must also have a compact package size and weigh less than 3 pounds. The operational need is to improve upon the current mobile aircrew tether systems, which have limited safety features. These are often fixed-length straps, which require the need to be continually manually adjusted. The adjustment process takes additional time that could be utilized for mission duties, and the continual monitoring can cause this process to be neglected. A new device, such as the one pictured here provided by Wolf during a Marine Corps user evaluation, can provide improved safety and mobility for all tilt-rotor and rotary wing platforms. To meet this need, Wolf Technical Services developed a solution that is a direct replacement for legacy systems, so it requires no airframe modifications. Our tether provides improved safety and mobility for aircrew, with increased survivability. Pictured here is the current prototype, a production equivalent unit with which we were able to show improvements over existing methods, including compatibility with existing systems that will attach directly to aircraft attachment points, improved functionality, usability, and mobility from the automatically adjusting webbing payout and retraction, with a 5,000-pound working load, compact package size weighing less than 3 pounds, and most importantly, designed to provide reliable fall and crash protection while allowing aircrew the freedom of motion throughout the cabin without inadvertent lock or release while performing typical mission duties. Since submitting this status document for PAO approval in July 2024, we have had to shift completion of the lab qualification testing to the third quarter 2025, rather than completing in the first quarter 2025 as we originally planned. This is still well within the schedule set by NavAir for the project, and we're on track for third quarter completion. We have recently passed developmental performance and environmental testing, with required qualification laboratory testing to immediately follow. Flight demonstrations and testing from specification are still anticipated to be completed in 2026. The primary differentiators for this system versus current technology include slack management, velocity lock, and payout control functions. Current fixed-length systems create webbing slack, which can cause a trip hazard for mobile aircrew. Wolf's system retracts webbing to prevent slack from building up on the floor. Wolf's system also has a velocity locking feature. This feature prevents the webbing from extracting after a threshold aircrew velocity has been exceeded. This feature is similar to a seatbelt you would find in an automobile in that during a crash event, with a high enough velocity, it will lock and prevent any further webbing excursion. This can keep the mobile aircrew from exiting the cabin or striking other obstacles within the cabin. But, much like a car seatbelt, current restraint systems with this feature go right into locked mode when reaching a certain speed, regardless of whether it's a real safety issue or not, which can interrupt mission duties. This is called a nuisance lock. Wolf's intelligent load lock feature senses the load in the webbing and only locks during a significant fall or crash event, preventing unnecessary stops. Nuisance locks were a highlighted deficiency of previously fielded systems that this feature fixes. In addition, Wolf's system has a payout control feature, which allows the aircrew to set a certain webbing payout length, creating a safe zone to perform mission duties. This feature can also help prevent aircrew, especially those working near an opening, from exiting the aircraft unintentionally. In 2023 and 2024, Wolf began a series of end-user evaluations, with our prototype tether systems on grounded V-22, H-1, H-53, and H-139 platforms. We were excited to receive excellent positive feedback and used aircrew suggestions to make iterative improvements to the system throughout our development process. Wolf's dynamically adjustable tether system does not require modifications to the aircraft for use, but is designed to be used on aircraft integration points already in use by existing fixed-length tether systems. These attributes allow this system to be easily integrated into multiple platforms, the need for additional budget or engineering exercises generally required for aircraft modifications. Wolf Technical Services, in conjunction with the Navy program sponsors, plans to complete flight qualification activities. We utilize a contract manufacturer with experience in manufacturing military products to manufacture, package, and ship the end product. An initial production run was completed in 2024, so we're immediately prepared to support future flight tests and additional customer interest. The initial target platform for Wolf's tether system is the V-22, although this system has application in any mobile crewed aircraft across multiple defense services. It also has applicability for law enforcement, medical evacuation, and rescue services. This system could also potentially be used as a fall protection device in industrial applications. Secondary organizations outside of the Navy and Department of Defense that could be potential customers would be the U.S. Coast Guard, the Department of Homeland Security, and various law enforcement agencies. The technology is safety critical. Wolf will be manufacturing and sell dynamically adjustable tether system directly to the government through our contract manufacturing partner, Merrill Technologies Group, which is a Kiel company. Wolf's current business model is to obtain support from NAVAIR program management stakeholders for acquisition of initial units and flight certification activities. Our first platform of interest is the V-22, and we plan to scale to support other platforms as our tether system is independently identified as a Phase 3 action for future year budgets to replace existing stock. With a successful Navy launch, we will identify and market to other service branches with compatible aircraft platforms who currently utilize the legacy fixed-length tether system. If you have any questions, you can reach out directly to the principal investigator, Aaron Tolley, the technical point of contact for this project, or the business point of contact, Amy Wortman. Our contact information is shown on this slide. More information or the ability to inquire further is available on our website at wolftechnical.com.